Something strange is happening at the edge of our solar system. A comet, an ancient icy traveler, has broken free from the sun's grasp and is now racing into the dark void beyond, faster than we ever expected. It's not just drifting away, it's escaping with astonishing speed, defying our understanding of gravity and motion. What could possibly give this comet such an incredible boost? Is it a hidden force, a cosmic slingshot, or something far more mysterious? For decades, comets have returned to the inner solar system like clockwork, pulled by the sun's gravity. But this one, it's rewriting the rules. Scientists around the world are watching closely, puzzled by its behavior. Could this be a clue to deeper cosmic forces we've yet to understand? Or even evidence of something stranger still? In this video, we'll explore how this comet picked up such unexpected speed, what it tells us about the outer reaches of our solar system, and whether there's something out there pulling it away. The object in question is Comet C 2023 Q4, an unassuming name for a truly astonishing celestial wanderer. First detected by astronomers using a powerful sky survey telescope in Chile, it initially appeared like countless other comets, a bright nucleus surrounded by a glowing coma, with a long tail trailing behind. It was far out, beyond the orbit of Neptune, drifting quietly through the cold and quiet frontier of our solar system. But as scientists began tracking its motion, something strange emerged. This comet wasn't following a normal elliptical path around the sun. Instead, it was moving fast. Too fast. Calculations showed it wasn't slowing down for a return journey. It was accelerating. And the trajectory, hyperbolic. That meant it wasn't coming back. Ever. Historically, we've seen comets that come from the distant Oort cloud, swing around the sun, and then vanish again for thousands, sometimes millions, of years. But this comet's path suggests it may be making a one-time visit, or perhaps it was never part of our solar system to begin with. This discovery immediately sparked excitement and confusion. Was this an interstellar visitor like Oumuamua? Or did something within our own system give it a final push outward? For astronomers, this is a rare moment, a chance to witness a celestial escape in real time, with questions piling up faster than the data can answer them. It's not just a comet anymore. It's a cosmic puzzle, and we're racing to solve it before it vanishes into the stars forever. To understand why this comet is escaping the solar system so quickly, we need to break down the science behind its motion. Every object in our solar system is held in orbit by the sun's immense gravity. Think of it like a giant invisible net pulling everything inward. For something to escape, it needs to reach what's called escape velocity, a speed fast enough to break free from the sun's grip. For an object near Earth, that's about 42 kilometers per second. Out near the edges of the solar system, the sun's pull is weaker, but even there, most comets still stay bound. So how did this one break free? Scientists are looking closely at two possible explanations. First, the comet's trajectory suggests it may have originated not from our solar system's distant Oort cloud, but from deep interstellar space. If true, this would make it only the third known interstellar object to pass through our neighborhood, after Oumuamua and Borisov. But there's another theory. It's possible that the comet was once part of our solar system, but something gave it a sudden boost, a gravitational slingshot. Perhaps it passed too close to Jupiter or another massive planet, and their gravity hurled it outward, like a rock flung from a spinning sling. Researchers are using advanced tools like the Pan-STARRS survey system, the Very Large Telescope in Chile, and even simulations on supercomputers to trace the comet's origins. They've analyzed its speed, its angle of approach, and the composition of its tail. Early data suggest a high concentration of carbon monoxide, an indicator it may have formed in extremely cold conditions far beyond Neptune. That supports the idea it came from deep space or the far-flung edges of the Oort cloud. This behavior isn't just fast, It's nearly unprecedented. The last time we saw anything like it, it rewrote our understanding of the solar system's boundaries. If this comet is indeed an interstellar traveler, then it carries secrets from other star systems. Mysteries, locked in ice for billions of years. And if it's local, then something in our own system is playing a much more active role than we imagined. Either way, it's a cosmic revelation in motion. Unlike a star on the brink of collapse or a supernova waiting to erupt, this comet isn't building toward a grand explosion, but its journey is still time-sensitive. Right now, it's speeding toward the edge of our solar system, and soon it will be too far away to study in detail. In just a few years, it will fade from even our most powerful telescopes, disappearing into the darkness between the stars. And here's the catch. What we're seeing now may have already happened months ago. That's because this comet is so far away that the light reflecting off its icy surface takes time to reach us, meaning we're always looking into the past. If it does something unexpected, breaks apart, emits strange gases, or changes direction, it may take days or weeks before we even know. And yet, scientists are watching it like hawks, capturing every photon they can. Because this isn't just about one comet, it's about what it might represent. Could there be more like it? Could we be on the edge of discovering a whole new class of objects, or even detecting activity from beyond our solar system? As it moves farther from the sun, its glowing coma and icy tail will gradually dim. It may never shine like the full moon or light up the daylight sky like a supernova. But in the quiet, it tells its own spectacular story, one we're only just beginning to read. Now, let's imagine the unthinkable. What if this comet doesn't just fade quietly into the dark, but suddenly explodes? While rare, cometary explosions can happen. These icy bodies are like frozen time, capsules filled with volatile gases trapped under ancient crusts. If internal pressure builds too fast, say from solar heating or a violent fracture, the comet could burst in a sudden, radiant flare. Imagine stepping outside one evening and seeing a brilliant flash across the sky. Not a shooting star, but a slow, burning, glowing cloud stretching for miles. The tail, once thin and wispy, now erupts into a fan of light, visible across continents. In darker skies, it could be seen with the naked eye for days, maybe weeks. City dwellers, rural stargazers, everyone looking up, witnessing a spectacle etched against the stars. Depending on its distance, we might see a glowing patch that rivals Venus or even the full moon in brightness. It wouldn't be sudden, like a supernova, but rather a majestic bloom, a cosmic flower unraveling in silence. Telescopes would scramble to capture every frame, and headlines around the world would erupt in awe. And emotionally, it would be humbling. A comet exploding on its way out of the solar system would feel like a final goodbye, a luminous farewell from a visitor we barely got to know. For our generation, it might be a once-in-a-lifetime sky event, a reminder of how fragile and fleeting cosmic encounters can be. This comet, whether it explodes or simply drifts away, holds profound scientific value. It's not just a chunk of ice and dust, it's a messenger from the most remote corners of space. Inside its frozen core are materials, unchanged since the birth of our solar system, and perhaps even older. Studying it gives us a rare chance to look back in time, to analyze the raw ingredients that formed planets, moons, and life itself. If it does erupt, the event would be a treasure trove for planetary scientists and astronomers. The explosion would release particles we've never seen before, complex molecules, organic compounds, or isotopes that hint at environments far different from our own. It's a window into chemistry that may exist around distant stars or in the deep void between solar systems. And while comets don't forge elements like gold or uranium the way massive stars or neutron star collisions do, they are part of that grand cycle. Comets spread the building blocks of life, carbon, nitrogen, water throughout space. Billions of years ago, it may have been comets like this one that bombarded Earth and seeded our oceans with the ingredients for life. Every atom in our bodies, our bones, our blood, our breath, was forged in ancient stars or carried here by icy travelers like this. That's the beauty of cosmic recycling. From VY Canis Majoris, one of the largest stars ever found, to a small, mysterious comet on its way out, everything is connected. These events remind us that we're not just observers of the universe. We're made of it. Despite how dramatic it all sounds, there's no danger to Earth. Whether this comet explodes, breaks apart, or simply drifts into the void, it poses no threat to our planet. It's far beyond the orbit of the outermost planets. Too distant to affect us physically in any way. Even if it were to release a burst of energy or gas, it would disperse harmlessly in the vacuum of space. At most, we might witness some fascinating side effects. If particles from the comet interact with the solar wind, they could create brief, beautiful auroral patterns near the poles, dancing lights that ripple through Earth's upper atmosphere. These are harmless and awe-inspiring, a visual reminder of our connection to space. And thanks to advanced instruments like neutrino detectors, massive underground observatories built to capture ghost-like particles, we'd likely know of any energetic event before the visible light even reaches us. These detectors act as early warning systems, alerting scientists across the globe within seconds. It's a silent, global network that's always watching, always listening. So rest assured, while the story of this comet might be extraordinary, Earth remains perfectly safe. We're witnessing the final journey of a wanderer, one that may have formed before our planet even existed. This isn't just ice and dust tumbling through the void. It's the silent echo of the cosmos, whispering stories older than human memory. Whether it fades gently into the night or surprises us with a brilliant farewell, this comet reminds us just how little we've seen and how much there still is to discover. It's humbling to realize that its path, its speed, its escape, was set into motion millions of years ago, long before our ancestors looked up and wondered what those glowing trails in the sky could mean. And now, for just a brief moment, we share a sky with it. Then, like so many cosmic visitors before, it will be gone, lost to the endless dark, between stars. But in that brief encounter, it teaches us something powerful. The universe is alive with motion, mystery, and meaning. We're not standing still on a quiet rock. We're part of a grand, unfolding story, one where even the smallest comet plays a role. So keep looking up. There are still secrets in the sky, still wonders to witness, and still stories waiting to be told, written in stardust, drifting just beyond the edge of light. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. We'd love to hear what you think about this cosmic traveler's final journey.